So first, a little prayer to the demo gods. What we're about to do today is a very interesting experiment because we haven't shown this to anyone before, and everything compiled for the first time about 3 hours ago. And it's been about 2 years of non-stop engineering work from about 40 people around the world here. So let's have a little bit of fun. So I am the founder and CEO of Codenvy. Thank you for the warm welcome, Paul. Can everybody hear me? Am I projecting good enough in the back? I got some head nods back there. Okay, great. I would like to introduce to you Eclipse Che. It is a next generation Eclipse IDE. It will be announced at EclipseCon that this is the next generation platform. If you are not familiar with the Eclipse IDE, it gets 2 million downloads a month. It's a crazy number of downloads a month. It is one of the world's largest IDEs of all time. It is well over 15 years old at this point in time, and it has its interesting qualities about it. Let me do a show of hands. First of all, how many people in here are programmers? Wow, okay, almost everyone in here. And then which side of the house are you on? Are you enterprise or ISV? Enterprise is software. You work for a software company like like what I do. I create products to sell to other companies. So enterprise, most ISVs? No, okay, cool. All right, how many people in here whose favorite tool is IntelliJ? Most hands. NetBeans? 1, 2, and anybody who's Eclipse? Who's the favorite? Wow! Your favorite tool is Eclipse? Okay, that's pretty impressive. Some of you voted twice, okay. Did I leave off any tools like Sublime or Notepad++, VI users? VI, yes. Okay. All right, okay, good mix, good blend. Okay, so I'm gonna hit, that's probably not all that readable, but we'll get there. The upcoming images are a lot more readable than this. But first, just to acclimate ourselves to what we're talking about here, the world's broken into 3 categories. There's the hosting of the apps where you run it at production. There's the delivery of your applications, which is now continuous delivery, continuous integration, and it's that complex pipeline from the point in time that the code has been committed to the time that it is deployed out into the production. And then there's the development of the apps. And we're all probably very familiar with source code management, issue management like Jira, your agile project management, and your IDE, right? These are all common things. You probably all have them in your environment. But one of the things we don't talk about is the workspace, right? We talk about the IDE, but we don't talk about the workspace. And we're going to do a little bit about that here. Before I get into that, I want to tell you actually a very personal story of mine. It was a very nice bio that Paul threw up. I once was very capable technologist. So much so that I got to travel around the world. I was like 22 years old. I was flying around for BEA at the time. I had written 3 books on Java, published them. That was a good time. I had over 8,000 pages of published material related to Java and the work that I was doing. And I was working on some of the world's largest e-commerce implementations in the 90s. Half of them succeeded, half of them went bankrupt. So that was kind of fun on that, all for BEA. Being young and cocky and ambitious, at some point in time, after 7 years at BEA, I wanted to pursue a career in management. And so, because that's where the fame and the money and the power all come into play. And so I went off and I did that. And I went into product management. And product management is a very challenging discipline where you need to have a technology influence and background, but you're not necessarily a technologist. And I spent 7 years at a great company, Quest Software. They were in systems management, so a little bit away And I grew up in the ranks very quickly there. I got to an executive level position, a VP. I was responsible for about 30 products and about $300 million of revenue for them. It was a good time. It was fun. You were all over the place doing all sorts of things with different people. And in 2010, I got really sick. And it was so sick that it took me offline for 9 months. And at the point in time that I was offline, I had lost some of my cognitive ability. And I was actually really worried about how I was going to maintain my career. I eventually recovered very well. I'm fine, no residuals, life is good. But on the other side of that, I realized, you know, what am I doing? This management career did not feel as fulfilling to me as the technology, the joy and excitement that I got from working on Java in the 90s. And so when I had fully recovered, I said, I'm going to reacquire these skills. I once was a badass. No reason why I can't be a badass again. Am I allowed to say that on camera? Okay, all right, yes. So I decided, you know, to sit down with the world's most popular IDE, with the world's most popular application server, on the world's most popular operating system, with the pet store application, and I'm going to go get hacking at this. And, you know, lo and behold, the world had moved on without me. And I don't remember giving it my permission, but it had just decided to go in a different direction, right? Maven was not around when I was hanging out, right? So this whole configuration management approach just did not make any sense whatsoever. Aspects and dependency injection, those were, you know, certainly not hanging around. Most of the collections, generics, all these sorts of things, just everything had been different. The data tier had moved on, right? We were getting into NoSQL at this point in time. And as a result, the tools in support of this stuff had gone from barely tolerable to infinitely complex. I didn't mind all that stuff. What I did mind is that I spent 3 days trying to get this stuff to work, and I never got it to compile. And I was embarrassed and humiliated that how could I go from, you know, being in one position to taking stuff off the shelf and being unable to get it to work. And I was frustrated, and it was beyond the humiliation. I was really upset about how are smart, interesting people supposed to engage with technology that I personally am a huge fan of when I can't even engage with it. And that was really frustrating to me. And it was at that moment in time that I had the original idea for Codenvy. And I was like, I just don't understand this. Why can't I just click on a damn link and it should just magically open up and everything that I need should be there, configured exactly the way that it needs to be configured. Right? This isn't rocket science, right? You know, this is a repeatable, scripted, recipe-based approach. So why can't we structure that and come up with that? And that was the basic idea. And so in 2010, we decided, like, why can't it be that? And that is the bag. If you study business at all, big, hairy, audacious goal is a great thing that you do, which is this goal that you set, which may never actually be possible, but you actually set it and you go forward with it. And the goal is that I think anybody, anywhere, at any point in time, should be able to contribute to a software project without first installing any software. And if you think about that, right, I mean, all of you guys are programmers, and every time you take a new job, what's the first thing that they do when you get into the new job? They give you your login credentials, and then they give you a link probably to some wiki, right? And they're like, hey, follow these instructions to get your development environment set up, right? And it's something that looks like this, with access, you know, all sorts of access controls, software that you have to install. And if you don't do it just right, it's just ultimately not going to work for you, right? Why is that? You were hired to be a programmer. We were hired to want to work on the logic, not to be the infrastructure engineer on this, but yet that's what we had to become. In order to do this, right, there's some basic principles. You should never have to install software. You should be able to participate in any branch flow, whatever that is designated by the project, whether it's an open source project or an enterprise here. And the resulting project should always compile and run, or stated differently, it should be in exactly the same state that the previous person left it there. So if the previous person left it in a way that it was compiling and debugging, then the next person in should do the same thing on that. So how do we go about doing this? Well, the first is you got to start with the link. And let's say there's some magical a link here. We call it a factory. And the purpose of this factory is that it is a reference to a project. And that reference has a script, or if you will, a definition, a recipe inside of it that will instruct the receiver of that link on how to basically deliver on that goal. So what it's going to do is it's going to either create a new or load an existing workspace, and then it's going to populate that workspace with the projects, the tools, and the configuration that it needs, including the source code. And then on top of that, right, in addition to getting all that stuff in there, it's going to need a runtime, because you're going to need to compile, you're going to need to debug, you're going to need to run source code analysis. All those things are processes. Processes need a runtime. And that runtime has to also be configured. Right, so it's going to need to create that runtime. And then after all that stuff is done, we need to onboard the acceptor of this link into this workspace so that they can get to town on that. Right? If we did this, then that starts to achieve the goal. Right? So if that was the basic goal, we recognize that what this comes down to is you have to create a portable workspace. That the unit, the atomic unit of what the world needs was an atomic workspace. And that when you look at the workspace definition that comes with your IDEs today, they are insufficient. The workspace definitions include your projects and your configuration, but it's ultimately not portable. And what we mean by portable is that you should be able to define a workspace, and its entirety is self-contained, so that if that workspace moves to another machine, it will operate exactly the same way that it was on the first machine without having to set up any additional software. So in order to do that, we wanted to go back and redefine the workspace to be a much broader concept. And I'm about to introduce Eclipse Che and why we created that. But Che defines workspace as a combination of projects and runtime environments. And they are composed together. Those runtime environments can be constructed of machines, and we'll talk about these machines. And these machines can power a number of different aspects of runtime that's there. But if you marry your projects and your runtime environments together into a single package, then this package can move to any type of infrastructure, and it's going to run in exactly the same way. Your projects are clearly bound to repositories, and your machines can be bound to various clients, whether it's an SSH client, a RESTful client, an IDE client, or whatnot there. So we needed to redefine that workspace. Workspace portability was essential. So once we realized that we needed to do a workspace and have a portable workspace in that regard, we said, okay, now we need to define a next generation platform to distribute and manage these workspaces. And so Eclipse Che was that platform. We embodied it. And what it does is it will take a workspace and it acts as a workspace server. So you can create workspaces, you can run workspaces, you can access those workspaces, you can export them up to the cloud, you can import them from another location. Right? So it acts as this very general purpose workspace management. It's a little bit hard to see, but our architecture, Che is a server. It's a workspace server. And it hosts a Cloud IDE inside of it so that you can access it through any browser. And it also gives you the ability to provision workspaces. The workspaces themselves are outside of Che, and they have their projects and their runtime environments. And we use Docker to power those runtime environments for each workspace. So the basic flow that happens is that Che comes online. It hosts the ability to manage workspaces. There is a hosted IDE so that a browser can connect to that. It downloads the IDE as JavaScript and CSS, and it gives you all the rich interface that you would have with the normal Eclipse IDE with a thin client. But then this thin client can interface directly with the Che server to create workspaces, or once a workspace is created, the Che server injects plugins, projects, synchronization, and developer tools into the workspace, and then makes that workspace accessible to the browser. And when we do this, this is obviously an architectural approach, suddenly workspaces can become portable and we can move them into any location and they're going to operate exactly the same way that you left them. So that's Eclipse Che. It's an IDE, it's a workspace server, and on top of that, it is a completely customizable framework as well. So it supports plugins, extensions, and you can package this all up into assemblies that are distributable as well. So you can create your own IDE, you can create your own tooling, and distribute it how you see fit. So let me pause there. I have obviously plenty of demos right, to do on this. Any initial questions?
They're awestruck.
They're awestruck? Oh, like awestruck isn't good, or this is the stupidest idea I've ever seen in my life? Yes, sir.
So the workspace that got created on Docker, can I just get it on my local? And
Oh yeah, we're gonna be, so these workspaces, so Che is packaged as a desktop IDE. And so when you install it, you can either run it as a server, as like a hosted server for other users, or you can package it up for single use on your computer, which is what I'm running it here. But as a single use on the computer, even though I open up the browser, just behind the scenes we're launching the server. The server's still running. It's just running on localhost for you there.
And I can only access that workspace using the browser.
No,
Can I use that just?
you can use an SSH client. You can use any IDE you want because we're going to give we give direct SSH and RESTful access to every workspace that's there. I'm going to show that. What's that?
Any IDE?
Yeah, because any IDE supports SSH. So you could bring up IntelliJ and SSH into this workspace if you want to.
Just on the hardware side, is it limited to Linux? Like you mentioned.
Linux, Windows, and Mac.
But the actual compilation happens all on the Linux side, right? Because Docker only runs on.
So so what we do for Windows and so the workspace. We technically support local host machines or Docker machines. You don't have to use our Docker. And on Windows and Mac, we require VirtualBox. And so Che takes care of detecting VirtualBox and then spinning up the machines behind the scenes, so the user doesn't have to do any of that work. The user just has to install, and our installers install VirtualBox for them on that.
So basically, Docker container is still running in your local system through the VirtualBox maybe?
If you have it set up that way. The default configuration is that VirtualBox running side by side with the Che server, but you can put the machines on distributed nodes if you wanted to. And essentially, my company Codenvy, the only difference between Che and Codenvy is that Che is intended as kind of a single server, single user experience, and Codenvy runs it on a Docker swarm, highly distributed, up to 1,000 nodes on that.
Just because, are you using Docker tools or are you using your own implementation?
What, you mean Docker Toolbox?
Yeah.
So Docker Toolbox just provides a Docker machine. And yes, we're using Docker machine to launch the VMs behind that. Okay? So, the beta build was just made a couple of hours ago. When I woke up this morning, there were a few regressions. That was a little of a heart attack. All right. So is that even remotely? How's that?
Good.
That's the screen? Okay. So, first of all, responsive design for your IDE, which is kind of cool. I can get serious zoom on this if I need to. Never had an IDE do that. This is the dashboard, and so all I did behind the scenes was I started the server, and then I went to. You can barely see it, but I'm at localhost 8080. That's all it says. I'm at localhost 8080. Dashboard comes up, and now I want to create a project. When you create a project in this type of world, it's not just good enough to clone some source code. You got to then tell the source code, well, which workspace are you marrying it to? Which means you got to pick your runtime. So here, let's do an import. I'm going to import this GitHub project. It's just hello world in a jar file with Maven. That's all it is, nothing more on that. And now, I need to choose my runtime. And we have these things called stacks. Stacks are essentially just a nicer way to choose an image. And if you're not familiar with what a Docker image is, it is essentially a templated definition of an operating system plus frameworks plus other stuff that we're going to instantiate. Now, we've got some ready-to-go stacks that for the beta, we've got 4 of them here. We've got a Java, a Node, an ASP.NET, and a PHP one. We are going to build up a stack library where we will have hundreds or thousands of stacks where you can choose from. You can see that our engineers are starting to build up some of this, right? Or if you want to, you can write your own stacks as well. You can provide a Docker file. There's some rules that we have around providing those Docker files, but you can write your own, and we can go from there. So I'm going to choose the Java stack. I'm going to give this stack a name. We'll call this the workspace that we're going to create with this. We'll call it the San Diego Jug. I need some RAM. 1 gigabyte is not really going to get us very far, so we'll give ourselves 3 gigabytes. And then we'll give it a project name, Hello World. And then we get to the create. So now what's going on here? There are 3 things that go on when we create a project. The first thing is we have to either load or create a workspace. In this case, that starting the workspace master is the process of getting the machine. And so we go out to look locally. If you don't have an image cache, we'll then connect to Docker Hub or a private registry that you set up, and we actually download the image. Now I read this demo before, so it was instant here, but this image would be about 170 megabytes if you didn't have it the first time. After it got that container set up, it then had to inject and start a Workspace Agent. So after the container, your workspace is set up, we actually then, post-installation, connect into it and install a second Che server inside the workspace. We call it a Workspace Agent. We then have to boot that server up, and inside that server, we take all the plugins that have been deployed into the system, and we install them into the workspace itself. We then inject a secure shell daemon inside of it, and there's a bunch of other tools that go into it. Now we're going to do a Java project here, and I'm going to show you a bunch of Java Intellisense that is running as fast, if not faster, than on localhost. And the reason being is that the Java plugin actually takes the JDT core from the Eclipse Foundation, injects it into the Workspace Agent so that it's running inside the container side by side with your code, and then it puts a RESTful interface around it. So that Workspace Agent, it's all RESTful. And so now we basically took the JDT core, which provides Intellisense like autocomplete, And now it is distributed and accessible from any client anywhere. After that, the third step was we actually needed to create the project. So it did the clone, and it then synchronized the project so that there is a copy in the Che server for long-term storage, and there's an identical copy in the workspace. And so if I modify either one, they stay in sync as well. And so all that happened, and then boom, and I say, would you like to open this in the IDE? And we go, good, yeah. And now what we have is a single page web app, which is a Cloud IDE here that has my project. Our designer is very good. He has a meticulous attention to detail on this. We got to give him a lot of credit. This is kind of a boring interface here, but essentially we've got an IDE. It's got menus. It's got a very simple toolbar. This is where we run commands here. And we've got panels along the edges that we can expand and collapse. And we've got, you know, a message here that the workspace was started. So it's all good. So I'm going to double click this project. And this project had a type associated with it. And I don't think it recognized the type on this one, given the nature of it. So I'm going to come in here. I got to zoom out for a moment. But I'm going to choose the project configuration. And this is I'm going to apply a Maven project type to this. And it gives me a wizard. Does it remember? Oh, did I import the wrong project? Just give me the C. Oh, I imported the wrong project. Or I came across the bug. One of the two.
It's okay. Don't panic.
Yeah, that's the right project.
Import twice, comes up C.
Yeah, it's interesting. Should do it this way. See what happens here. That's cute. C++ project.
How many different languages do you support?
Well, on the Intellisense one, right now just Java and JavaScript. But compiling and running, pretty much anything here, as long as you can get it into a container. There's the server started. Create the project, cloning. Good. There it goes. Okay. So it saw the palm, and it got the. Okay, good. Good. So it's Maven. That was weird. That was very weird, actually. All right. So so it's detected that it's a Maven project, and so when I open this, you can see that it's going off and updating the dependencies. So if I come in here to the outputs, it's actually already going and downloading all the artifacts for this project and installing it into a local Maven repository that's inside my workspace. Right? Which, if I choose to export this workspace and move it somewhere else, that Maven repository and all the downloads are going to go with it as well. So automatically going with that, we're going to let that go to town. Let's have a good time. Let's open some files here. Nice editor. This is an Orion editor. Orion web editor is very rich. There's a lot of capabilities that you've got. You know, I've got a find mechanism here. Close that. In the assistant, if we go to the key bindings, I can show you that there are plenty of editor capabilities. Great internationalization and localization support. You can see that we've got the view on the left. So all on the right there. So all pretty good, rich stuff for a editor in the browser. But we're developers. So here's the hello world. Right. First thing is that we want to start doing some Intellisense here. Now I just put my cursor in there and I hit Control Space, and there was about a 1 second lag for that to come up. And that's because the first time the JDT ran, did its analysis on my code, and then I needed to cache the proposals back. But going forward, it's instant here. And we can start to do a lot of things in here at the same speed that you can do it on your desktop, even though we're doing this over a browser. And in fact, when we start doing this in our labs and we start distributing these, we actually can create experiences that are faster than some of our developers' desktops, because we can put the workspaces onto nodes that have no thrashing or blocking or conflict with other resources. And so if you get the workspace set up in the right way, it can be pretty screaming fast here. So we've got annotations, right? This is telling me to get rid of the to-do here. That annotation goes away. I could come in and do import org dot star. I could type today, star, and it's going to tell me, geez, that import is never used. I can hit Alt-Enter here to ask for some proposals. It gives me some help, and so I can remove that unused import. That's all well and good. Let's clean this up. So let's replace hello world with a method here. So I'm going to go and create a new class. My class. So public int my field, public string my method, return so that looks good. So I can come in here and I should be able to do an autocomplete, and yep, there's my class already. Even though this is distributed out in the world, I've already got access to my class. So that's very encouraging to see. All right, and then what we want to do is MC dot, and there's my method on that. That's nice. All right, cool. If I need to, I could come here and Alt-Enter. I could extract this to a local variable. Okay, I could undo that. No big deal there. All right, so we've done that. All right, kind of fun, all in a browser. Now it's time to compile. This is we kind of needed to redefine the nature of how you go about building and running projects in the cloud. First, I'm going to rename this to make it a little bit simpler for us. We have a concept called a command. A command is something that derives itself into a process, and then that process needs to be executed against a location. So we're talking about this workspace as having a runtime, but what if your workspace has multiple runtimes? There's no reason why it couldn't, right? When we're on our desktops here, we think of localhost. Localhost is a single runtime, but when you're in the cloud, why not have 2 runtimes, or 3 runtimes, or 4 runtimes? You can have as many as you want. If you're going to build a command, you then have to be able to define that command, derive it into a process, and then target that process to a particular machine that you want it to run in. So in this case, we have a build command here. It's going to take that build command and apply it to the current context of the IDE. So I can click in different locations inside the IDE, and then the command is going to be executed in that context. And here, this just is a macro that says the current path of the IDE. And then it's going to run clean install. And this particular command is of type Maven here. And so it's got some intelligence around that, and we don't need a preview for this. I'll explain that in a minute. So we're going to hit save on this. We'll hit close. And so my cursor is currently in this project. I only have one project here right now. We can have many. It's a Maven project. And so if I say build, off it goes. It brings up the console, and you can see the translation of the command, and it is Maven-F to this project directory, clean install, and there it goes. It's going off to town on that. And what it did though, is it took this build command and it injected it into this machine. Now I only have one machine in this workspace at this point in time, but I can have many, right? And then I can choose which machine I want that process to execute against. Okay. And it's going to execute that process against the particular project tree, and lo and behold, it went to town, and it's all good. We're happy here. So now I suppose we want to run it here. Let's go ahead and edit these commands again. I don't want to really use this built-in one, so let's go ahead and do a custom one. A custom one is anything we can do, and this is just echo hello. So I'll save that. Go ahead here. We'll go run. And there's our run command, hello, on that. It's not the right command, so now we want to go in here, say java-jar, and now you need to know the location of that jar. I always forget this. /target. I gotta save, I gotta go check it out. I can't remember where this is. And clearly if I run this now, it's gonna give me some error. Okay, so where can I go and find this thing? Well, why not go into the terminal, right? Here's Midnight Commander. So here's a terminal into my workspace. I've got Midnight Commander running here. PWD, so projects, help console, Java simple, target, and there it is, console. I had the whole thing, like console-java-simple 1.0.jar. So if I come back in here, we could edit this commands. Console-java, was it? Java simple. That's old age for you. Snapshots. .jar. Haha. All right. Yeah. Demo gods are being friendly to us here. You can use our terminal. You could have many terminals. Why not? On that. Or you could just SSH in to this, right? And we give you the instructions on exactly what you need to do to SSH into this machine. And what we do is every machine has its own secure shell daemon inside of it. You just upload your keys into each one, and you're ready to go on that. Okay, so we don't need some of that. We could, come in here and, to show off some of the context sensitivity. This is just which class am I? And here it's echo, and we'll use a, I think it's current.class.fullyQualifiedName command. Is that right? And if I run it against my class, it's org.eclipse.che.examples hello world, so it's actually got it there. And if I run it against my class, there it goes against my class on that. So all kinds of macro commands that are context sensitive to where the cursor is. And so in this, one of the things that it took us like 9 months to engineer is this is not a single project workspace. You can have it up to, I think, something like 1,024 projects in here, each project bound to a separate repository. The actual Che project itself, I think, is 10 repositories. We have 2 dependency management Maven repositories. We have Che Core, which is our platform. There's a plugins repository, an assembly repository, a dashboard. So every repository is there, and they're all Maven multi-module repositories. So you can bring them all in, you can, and then you can build and run any particular module or project as you see fit while still having them all in one workspace. So it's replicating the same sorts of things that you would do on your laptop, but just in a distributed fashion. Here. Let's see. All right. No reason you can't debug in the cloud. So debugging in the cloud is interesting. So I just set a breakpoint there just by clicking here. I'm not running the process, but it lets me set the breakpoint. And there's full step in, step through, step over capabilities on this stuff. But debugging in the cloud is a little bit trickier because all debugging is distributed. There's no such thing as like a local debug. Everything is a remote debug process. So since you're debugging inside of a workspace, when you go to do a run, everything's a remote debug. And so what you have to give is when you give the host name of your debugging port, you got to give the host name of the machine that's running inside your workspace and the port that's there. And we give some instructions on how to connect to that, and we give some discoverability. We have a macro that basically you type that macro in, and we will go and figure out where your workspace is, whether it's inside of a VM or it's on another machine. We'll figure that out for you. That's cool. Why not do your version control here? So we'll just type in the git status, and we've modified this. And we could do it from this git menu. We've got a bunch of capabilities here. Or I could open up the terminal. See, projects. We were in what console? And same thing here. And you know, I can actually do a git add, git commit. I cannot believe it has worked so far. Right? And it's asking for some configuration stuff. And I could push right back to the repository that I came from because, you know, when we cloned, it was smart enough to set up the remotes, and it's actually got the origin here on the remotes that we came from on that. Okay, all right. Let's pause there. Questions? Yes, sir.
I love my shortcuts.
What's that?
I love my shortcuts from IDE.
Yes.
What are they here?
Are there any shortcuts? Yes, these are all shortcuts. Or are you thinking something different than?
No, this is like
Yeah.
shift control.
Yeah. So we got them all there. For the most part, they are. We don't yet support letting you change the key bindings. You have to use ours at this point in time. For the most part, they follow the IntelliJ key binding philosophy on that. There are, we also in the menus we provide all the, you can barely see it, but these are the quick key bindings here. One of the things I forgot to do, which is usually part of what I would like to do in the demo, is developers cannot live without refactoring. So I could put my cursor here, do Shift F6, and you can see that I could rename it in line, but if I do it a second time, there is a refactoring dialog box. So let's just call this San Diego. And I can go to the preview pane, and we can expand that. There's nothing to see there. But when we go down here, you can get a diff view of what's going to change on this. And if I go ahead and hit OK with this, yeah, that happens. That didn't work. Yeah, this is one of our known issues right now. It's like it only works like randomly. It'll get there. It'll get there. We've got good engineers. Yeah, that's not good. Actually, it would rename the class in my file, rename it in the tree, rename the core class up there as well. And we've been having some weird ghosts in the system. But, you know, like I can come here, I should be able to, for example, come rename this package and say I was, examples was the wrong package, I wanted it in samples, hit OK. This is probably going to fail on me here. Oh, actually, it did it. All right. So it renamed it here, it renamed it here, it renamed it not here. Yeah.
But you have the my class San Diego right now. It looks like it changed within the file tree.
Oh, it actually did rename it.
Yeah.
Yeah,
Can you double click on
but
it?
it didn't update it for some, yeah, so if I double click on it, yeah, you're right, yeah. Yeah, we'll chase that stuff down. There's definitely work to be done, but you know what's interesting is that when you refactor in the cloud, we're refactoring it inside the workspace, and then it gets synchronized off to the Che server, right? So the refactoring is touching, and then we have to update the syntax tree, the in-memory syntax tree, and then push the changes off into the browser so that when you have the Intellisense in the browser, that it's got the latest syntax analysis, right? So there's a whole propagation of issues that are going on here.
Is there a collaboration, for example, multiple people can edit the
Ah,
same file sometimes?
I'm so glad you brought that up. So collaboration. Che is a collaborative, it is a multi-workspace server. Now, Che, just to be clear, the workspaces are collaborative, but the server itself is single identity. So right now in the way Che is implemented, all humans that are accessing a workspace are sharing the same identity on that. So same key binding, same preferences and whatnot. But you can have as many users in a single workspace as you want. So you could have users SSHing in, you could have other users browsing in. They can be accessing those projects, running processes against it at the same time. We don't support yet multi-cursor editing. And so multi-cursor editing is when two users are in the same file at the same time and you can see their cursors, which is what you might do in a pair programming. But you can put two people in the same file, you just can't see what they're doing, and it's last right wins. Right? It's last right wins. Which, by the way, Google Docs is the same thing on it. You know, because we're just taking every keystroke and saving it back anyways. And so Google Docs, all they're doing is they take all the interactivity from all the users, and then it's just like first in queue, and then they execute the queue, you know, one thing at a time.
Since last edit we ran, are you able to see who's on the file and then you can maybe stop them?
That's another part of, no, we don't, because it's a single identity, we don't have any sort of like chat window where the person has that identity. Codenvy,
Cloudant, for example, I'm not sure you use that one. Allows you the collaboration and multi-cursor.
So, yeah, Cloud9 uses Firebase, right? So first of all, Cloud9 is only in the cloud, right? You can't install it, you can't run it. And because they're a hosted service, they use a service called Firebase, which allows for that multi-user interactivity. You know, Codenvy, we have a very, very, you know, lightweight version of that, not nearly as sophisticated as that. We've been reluctant to go too far with that because most of our enterprise accounts are on-prem behind the firewall. They're standing up their entire own system, customizing the workflows. And that means, for the most part, we have to be completely isolated. And so we can't tap into a service like Firebase because most of our customers will cut that sort of stuff off. And so, and we don't have the resources to implement, it's called an operational transform to do that at scale. And so we're a little bit limited. But at the end of the day, when you get into enterprise development, this idea that even if you have two people in one workspace, they are rarely in the same file at the same time, right? So the only times that you have two people in the same file at the same time is when you're doing like a recruiting job or maybe some rare debugging case. But even in the classic sense of pair programming, one person is writing and the other person is just watching on that. So
that's the only problem that I can see right now. If multiple people using the same file, obviously the last one will win always.
that's right.
That's going to be a little bit problematic in terms of.
Correct. It's going to be a bit problematic. Now, this whole system is extensible, so we are desperate for more community contributions. We'd love to bake in a proper operational transform. The challenge is not in coordinating the commits. The challenge is in distributing those commit messages to all the different clients so that the clients can see who's doing what at the same time.
This is a good break.
Yes, actually now's a great break on that. Okay, so thank you. Well,
Yeah, let's go ahead and take 5 to 10 minutes, use the restroom, clean up, and we'll be back for more of
Yeah,
Eclipse Che.
I've only got like 15 more minutes or so.
Okay, cool.